And then I'm not sure if there's any questions or feedback.
So, Killian, it was a wonderful session, and thank you for taking out the time on your Saturday afternoon to give us this session. It was really wonderful. Anybody is having any question from the participants? Please feel free to drop in. Otherwise, we can wrap up this session, and later on, you can reach out to Killian and Tiago for if you have any questions. They have been very kind enough to help overall community from last many years and has been helping all the members throughout. So you can reach out to Killian as well as Tiago. Both are MVPs,
So,
so you
yeah,
might be.
sorry, just one thing, Anuj. We are still in the middle of a session. Now it's not, it's the next part of it that is my part. So we
I see, I see, I
have
see. I see, I see.
we still
I
have
was not aware.
1 hour. No, but I think that yeah, I can continue from here because it was a very interesting concept that Killian developed for the
Agreed.
game, for the agent, and I also participated. I also went for a hybrid approach, but the way I implemented the deterministic part versus the AI part, it was quite different. So I think it's a really interesting way of how to show how we perceive AI versus automation in a different ways depending on our experience, right? So yeah, I will continue from here. Let me also share my screen, um, entire screen, and I believe you now can see AI or not to AI, right?
Yeah,
Also.
we can see it.
Okay, perfect. So also just doing a quick introduction of myself. So I started to work as an Outsystems developer 7 years ago, but in this last 2 years, I dedicated almost 100% to AI and AI integration with the Outsystems environments. And I also decided in the beginning of this year to create a YouTube channel, Tiago Talks of AI, that I share the findings that I get from using AI and also combining that knowledge with Outsystems. So not only about the agent workbench, because the agent workbench is quite recent, but also how we can go beyond the agent workbench. I was planning in a quick knowledge sharing, but I think or check, but I think we can skip because we are few in this call, and most of the questions were talked like 10 minutes ago. But this is one of the things that I want to focus for my part of the session. That is indeed how can we define what should be a scope of an AI agent or an AI algorithm and automation. So we will cover that a bit. Also going into the detail, because sometimes it's not about the full scope, but it's in reality going into the task level, right? Because, for example, we saw in some of the examples that Killian gave in the game that they could fall into it depends, because even inside of a full scope of a feature, we can have different subtasks, and then each of the tasks can be done, one by AI, one by automation, and another by human. So there can be a combination. So we are also going to talk about this. So for this hour here, we are doing just a quick recap of the agentic world that I talked last week, just to introduce the AI agent, and then we are going to focus the part of where to AI and where not to AI. And in the end, I'm also going to throw some examples just to see if there were differences between the results with Killian exercises, and I'm curious to see the results. So let's go. So doing here a quick recap. So we talked last week that an agent is not something that was born with AI. So an agent is a concept that we engineers and architects, we always like to put things into concepts. So an agent in reality is a concept that comes from the 80s, when it was introduced, the area of multi-agent systems, like in robotics, in factories, and so on. And there is this whole study around an agent concept. But what we can wrap up is that an agent is a sort of an entity, a closed entity, that has the capability of reading from the environment, then make decisions upon that information, and take actions according to the decisions, right? So if we have something, a piece of code, an entity, a person, an employee that follows into these three characteristics, it can read from the environment, it can make a decision and take action, we are talking about an agent. So this means that the only difference of an agent to an AI agent is what happens in the middle part of it. So the only difference is that an AI agent is an entity that has an AI model to take the decision, and then it also has all sorts of inputs, has sensors, and gives back all kinds of responses, has actuators. So this is the concept of an AI agent. It's just like an agent, but it has an AI model in the middle. And this also has a similarity, for example, for another type of agent that we know more as humans, right? So if we want to compare as humans, we can say that our brains, they are an AI model. So the brain alone, he cannot do anything, right? Because it needs sensors. It needs our eyes, our ears, our nose to receive information from the environment, then to process that information, and then to act upon the environment. And we can do that by touch, by movement, or by talking, for example. So if we combine the brain with all the sensors, this means our body, then we have an AI agent. In this case, we have a human agent, but to compare, it's the same level. So, and this was more detailed or talked more in detail in the last session, but I just wanted to make a wrap around this to assume that, or to establish what is the level of an AI agent. So now we go to the important part, where to AI and where not to AI. So last year, 2024, Deloitte made a study in the United States. So they evaluated 19,000 tasks in government, and their goal was to try to classify tasks to know to which type of agent it could be better given, to a human, an AI, or automation. And so they, based on the studies, they basically detected, or they identified three dimensions in how we can classify a task. So the creativity part, how much the task needs to have created outputs that didn't exist before. The context variability, so how much a certain task needs to receive or needs to adapt to the context and different types of inputs that could appear. And finally, how much a task needs to be precise. So we are talking about deterministic results. And so they created this triangle of to evaluate the tasks. And the funny thing about this is that if we would look back into the 80s, this would be really simple to draw a line between humans and automation, right? At the time, there wasn't yet concept of AI agents. So we had basically human work and machine work. And it was quite easy, or it became easier the more we grew up with having machines and humans, right? It was easy for us to differentiate what should be given to machines, what should be given to work. So basically, every time we are talking about a heavy, precise task that needs to be done without flaws, without efficiency, and that can be easily put it into rules, it has a precise way of explaining how to do it, as Killian said, then that would fall into machine work. And then for everything related with creativity and context adaptation, that was for us humans, because it's too complex to put it in rules. But then something started to happen, right? Because in the 70s and in the 80s, first really simple modules to try to simulate a sort of an artificial intelligence were created, right? So we start having like algorithms like linear regression. Then we start having, for example, introduction to neural networks. And then the neural networks started to become more complex and more complex. And then we started also to give concepts of deep learning and machine learning to the base of the neural networks. And more recently, something happened that was the introduction of the concept of the large language models. Right now, we already have more types, so we can have, for example, small language models. But this concept of a language model, it revolutionized completely the way we looked at AI, because so far AI was a very complex machine that could adapt somehow to the tasks. But with the introduction of the language modules, that went with a bit more to the side of the human work. And then we can see that with the appearance of the different modules that exist nowadays, right? And with this introduction of what it's called the generative AI field, we see that a lot of tasks, and most of the tasks that are being created nowadays with using large language modules, they are more in the field of humans and not in the field of machines. So it makes us think that in reality, we should not look into the precision part of the tasks to try to replace with AI. We should look at the human part of the tasks to replace with AI. And so they notice that taking these three dimensions, the automation falls more into the precise, and this was an easy one to get, I think. So everything that we see it nowadays as automation that has, like I think Killian put it really well in the bullet points there. So if we have deterministic behaviors that can easily be explained, they cannot fail because they are mission critical. So these are the typical tasks that we should give to automation. Also because most of the times they are boring. If we humans are not good with repetitive tasks because we become bored about them. We are not precise beings. So for us, repetition is not good also. But then we fall into the other two, right? So we have the humans, and according to Deloitte, what they notice is that, yeah, for now, tasks that are more related with heavy social interaction, like psychologists, sociologists, so they are still better suited for humans. And also an interesting field that is the complex physical tasks, because so far machinery has a lot of limitations compared to our human, to the easiness that we have to move things around and to understand the environment. So that part, I think if we would ask back 20 years ago to people, what do they think that artificial intelligence would replace in humans, they probably would all say that it would be these physical tasks, right? Maintenance, factory work, crafting. This would be replaced by AI, right? But in reality, no. In reality, what we saw is that Gen AI replaced, in reality, everything that so far seemed more humane. So artistic, generating image, generating text, summarizing, comparing specifications, but also generating code and functions. So in reality, we saw that Gen AI replaced exactly something that we were not expecting to be replaceable, because we thought that art and text, everything more artistic, even including code, we could consider code an art. We were assuming that this was a really human thing, right? But guess what? If you give human data to a very complex algorithm, the algorithm can also do human artistic tasks. So I think this is a very interesting idea. So we have the three types, right? AI, humans, and automation, the three agents. And if we look at all the types of interactions that can exist between these three agents, right? We can have 6 types of interactions, right? We can have human to human, we can have agent to agent, automation with automation, but then we can have the variations: human to agent, human to system to automation, and then agent to automation, right? And we can try to classify these in very different ways. So we can say that, yes, this is, for example, in terms of time-wise, the human and the automation is something that we are more matured to know. So I think any of us being here developers, we can really tell immediately if something can be automatized or if something cannot be automatized and we need a human decision here or a human action. So for us, it's really easy to detect that, because guess what? We grew up knowing already that and evolving on that. So it's a mature concept. And then we have AI, that is a disruptive concept, right? So that is the part where we struggle more to know where to fit. But also we can look into, for example, what was made by us and what is natural, right? So automation and agents, they were created by us. It wasn't an artificial creation. And we, as humans, yeah, we can also say that we create ourselves. I will not go into details on that, but it's a natural process. But what I want to focus here is not these two, but is this concept of communication. How do we communicate? Because if we look into the difference between humans and AI agents and systems, we can see that one huge difference is the way that they process information. Both humans and agents, we process unstructured communication, right? I'm here talking with you guys, and I'm not following a very strict syntax sentence, right? I'm not, even if we have a bit of a grammar rules, those grammars are more like guidelines. So I can decide if I say something to you guys more or less in a certain order. I can say I will go tomorrow to the park, but I can say also I will tomorrow. No, I will go to the park tomorrow. So I can put tomorrow in different places. So we talk with ourselves in an unstructured way, and also with agents, because the way they were trained and the way they act, they also are prepared to receive unstructured inputs and give back unstructured outputs. But with machines, that does not happen. Automation needs rules. And this means that they also need rules in the communication. That's why we have JSON syntax. That's why we have XML syntax. Basically, all types of syntaxes we can use to communicate with systems, they follow strict rules that we need to comply, right? We cannot do arbitrary creative ways of a JSON. No, a JSON is a JSON that follows these rules, and it will fail. The system will give an error or something if the JSON is not correctly written. So this is a very important characteristic, because this means that when we want to create multi-agent systems, right, that for each task it's done by different types of agents, we need to consider the way each agent is prepared to receive information, right? Because normally between humans, yeah, we talk. It's the more simplistic thing. We talk, and yeah, it's an unstructured communication completely. Between agents, for example, they can use the A2A protocol, and if you go into the specifications of that protocol, You may say, oh, but it's a JSON. Yes, no doubt about it. It's a JSON. But if you go inside of the JSON, you will see that you have a field for the agents to freely talk with themselves, to send messages between them. The reason why you need JSON is because an agent is still wrapped around the system, and the system is automation, so it needs to be prepared to receive the information, digest it, but then the specific part of agents talking with themselves, so the real juice part of the communication, you will see that it's a simple JSON attribute with open format for the agents to talk with each other. But then between systems is different, right? Because between systems, we need to have a structured communication. So that's why we have APIs, different types of APIs, REST, SOAP, and even other systems. We can have FTP protocols, for example. So, but we have all sorts of structured communication between systems. Then we have humans with systems. And because we humans are unstructured and systems are structured, we need to have a sort of a way to translate the two worlds, right? And that's why we have, for example, applications. And without systems, we see that a lot, that if we have an entity with 5 attributes and we want to create screens for that, right? We drag it and Outsystems already assumes, let me give you a list screen and an edit screen. And that is a way to translate structured communication, that is the entity itself with the attributes, into an unstructured thing, that is a screen, an image for us to interpret the screen, right? And for example, you guys can look at forms, right? A typical form to submit information. A form is nothing more as a conversion of an unstructured communication into a structured communication, right? That's why we have apps and actions to communicate between people and automation. With agents, it's a similar situation. So MCP came to solve that. So MCP also has, and I will not extend this because we talked to this last week, but MCP, it's also a way to connect unstructured system with an unstructured agent. And everything that exists in that protocol assumes that. And then finally, we have agents with people that we talk with them, and we can talk in a matter of writing, or we can talk using sound, but we always need an app. And the reason for that is because an agent does not exist, an AI agent does not exist naturally in the nature. It is put it inside of a system. So we always need a way to access that system, right? But the important thing is that we talk with them like we would do with another human. So one of the reasons why I wanted to bring this is because, as you guys saw in some of the examples that Killian gave, we are not talking about one task, but we are talking about a set of tasks. For example, in the credit card fraud, that is not one single rule to check if it is a credit card fraud or not. So probably if you guys will look into the full detection, right? It's something more close to a typical workflow. Probably it checks first some things, then if true, it's fraud. If not, let's go to the second step that we check another things, and we have a sort of a multi-step process that checks if it is a credit card fraud. And in those steps, we can see them as tasks. And even inside of those tasks, we can talk about subtasks. So we can check, for example, if in the credit card fraud, if the value is below a certain level, we can do something. If it is above a certain level, we can do another thing. And that's automation. We don't need an AI agent or human to decide that. It can be a simple rule, if below 500, if above 500. So this means that we can have automation inside a credit card fraud workflow. But then we can also have humans deciding that if it is a huge value and if this happened in this country or in that country, and it's not like so easy to create rules, like Killian said, that would consider to be a fraud or not, we can put a human or we can put an AI agent. And also an AI agent can have different characteristics that a human does not have. For example, he can be trained on better algorithms to detect credit fraud. He can be trained, instead of having a normal large language model like GPT, we can train our own machine learning model, really trained to receive, for example, hundreds of transactions. And it's impossible for a human to analyze hundreds of transactions, right? But if a model is trained only specifically for that, he will be more accurate in that task than a human. So in this case, we can also have inside the different tasks of a credit card fraud, we can have different AI agents trained with different AI models to do specific tasks. And we can also have a human in a loop to have a part of a human task. So you see that in most of the use cases that we will have with clients in projects, it will fall on the it depends, because it will depend on the full scope of the workflow of the process that we want to solve. It will depend on that, and it will also depend on factors like, for example, the client. If the client is more risk adverse of AI or not, if it is more mission critical tasks or not, or if we can give them to AI or not. So it will always depend on those situations. But one of the things that I noticed in these last 2 years is that it's really rare to have a use case that will only fall into one of these types of agents. Most of the times, it will be a combination of two, sometimes a combination of three. So how can we go from use cases into AI, right? Because so far I said that we can have these use cases, right? And they are really complex, and we can have AI, automation, or humans, but how do we really identify how we can put AI in use cases? There are two ways where we can do an approach on the business. One, it's what we technical people tend to do more. Another one is sometimes how it should really be done. So we can have what I call a bottom-top approach. So this means that we start looking into what AI can do, and then we go to the business with these. Or we can have the top-down approach, where we identify the business, we identify the different processes, and only after that we check if it is possible to use AI or not. So in a very or in a more detailed way, what I'm saying is that we developers and architects, we can easily have this layer in our heads. We have already a technical mindset, so it's easy for us to read, to test, to develop, and say, oh, I have an email reader agent that basically reads all emails that are put in a certain mailbox. I also have a summarize agent that can pick a large set of text and give instructions for him to summarize. And we have an image generator agent. We ask him something and he generates an image. So perfect. We have these three scenarios. Now let's go to the business. Let's check what they do. And let's then put the use cases in the different steps of the processes, right? We say that, oh, this one can be used there. This one can be used there. So this is one approach. But then we also have the other approach. And sometimes it gives better results, mostly when we will be talking with business people and not technical people. That is the top down. And with the top down, what we do is that we first look into the business layer, we dissect the different processes, the different steps, and only after having that really identified, we then connect to use cases of AI. And how do we do this? we can do this using a three-step process that we should first identify the different business processes that exists in our business or in a client, depending. So we identify the different business processes, sales, marketing, purchases, all types of it. For each one of these processes, then we dissect the process itself. We do a sort of a diagram, right? We basically do a BPT in our heads where we say, okay, they start doing this, and then the human needs to do this, and then it goes puts in the system this, and then we design the full diagram, right? And after having that, we then perform a cost value analysis on the human activities, and we will see why that it is on the human activities only. So if we go to different types of processes that we can have in a company, right? Like I was saying, the sales, marketing, salary process, employee onboarding, right? We can start doing for each one of them this analysis. And let's start, for example, with the sales, right? So in the sales process, let's assume that this is a really high level just for the example of this session, right? But we imagine we have this sales process, and then we start seeing, okay, how do we perform a sales in this company? So we start, or the client, someone starts submitting a sales order, then the sales order, it's sent to the warehouse for them to prepare the sending of the material, and there is then a plan of the delivery. Of course, that I'm mixing a bit here sales with warehouses, but just for the purpose of this. So we have these three processes, and we can even then dissect how a planned delivery works. Is that someone goes to the system, checks a calendar, how does it work, right? So we can also dissect that. But when we are okay into saying that, okay, we are on a task level, so right now we don't need to break it more, we are already in the details of each task, right? So that is the moment where you do a classification of which agent performs what task, right? And in this case, we assume here that the submit of the sales order is done by humans, so they receive emails from clients saying that they want to buy this and that, and so there is a human that reads that email and says, okay, I need to go to the system, to our CRM or ERP, and we need to create the order. We submit, and then on the warehouse they have in the system an automation that receiving the product, it knows already where the product is located, in which warehouse, in which row, and so on. And so it prepares that part, it prepares completely the delivery inside of the system. And then finally, to plan the delivery, we have a manager of the warehouse that basically sees that there is this and this to deliver to the same place. So he manually determines the delivery, right? So we have here three tasks, and two of them performed by humans, one performed by a system. There is already one task that we can take away from the equation. That is the machine task. And the reason for that is because if the automation works and they are happy with it, it doesn't fail, it is a good process, then we should not touch it, because it's already the most efficient task with a less cost efficiency process, because automation is always faster than humans and AI agents. So that one we can remove from the equation. This we will not touch. What we want to check is the human tasks. And these human tasks, then we pick them and we do a cost analysis of these tasks. So we see for all the human tasks that exists nowadays being done in a certain process or business, let's look at them in terms of cost. How much do they cost? For example, having a human doing that, including salaries and so on. How much value does this task brings to the business? Is this a high value task or a low value task? Is this prone to errors? So when humans are doing this because of the repetition and the detail needed to do that, is this something that costs a lot of errors and also a bit the costs of those errors? And if it is a repetitive task or not, because most of the times repetitive tasks are not tasks that humans are really happy doing that. So if we can remove the repetition, we have a more healthy work environment because people are not bored doing those tasks. They can do other more creative things. So for these four dimensions, we can then do a cost an analysis on each one of the tasks. And we can see that, for example, for submit sales order, the cost is really high because it's a sales order. It also has a very huge value because that's what our company do, sales. It has some error prompts because sometimes people receive a lot of emails and they are not so well specified, and so they assume things and they put not the most accurate information, the correct product or something like that, and it's quite somehow repetitive, right? For example, for the planned delivery, not so much. For the create employee, doesn't have such a huge cost, but it has a huge value. So we do this evaluation, right? And based on this evaluation, then we can prioritize the tasks we want to replace by AI or to evaluate if they can be replaced by AI. And only after this, we then go to the technical layer where we say, okay, now we know the tasks that needed or they are more important to be replaced because they have the more costs driven value for it. So now let's see how we can technically solve this. For example, submit sales order. The humans, they read from from emails. So let's pick the email reader agent, and at least we will have an agent reading all the emails that come. It doesn't matter if we receive 100 or 1000, he will be reading them. For each one of them, he will not be tired. He will not be prone to errors because of repetition or tiredness. So he will read the email. And then let's assume that because sales orders are quite important, we don't feel comfortable in having the agent directly sending the sales orders to the warehouse. So let's assume that we will for now put a human in the loop. So in this first 3-6 months, let's assume that the submit sales order will be broken in two subtasks. One task that will be done by an AI agent to fetch the information from the email and then converting into a sales order in a draft status. And then let's put the sales people that before they had to do this, let's make them just for now, just approve or change, edit, and submit the sales order, right? And by doing that, we are doing two things at the same time. First, we are taking repetition and boredness from the sales guys. Second, we are putting a human in the loop process here, but we are not putting a human in the loop because it is a fancy thing to do and everyone should do that, and because it's AI we can never trust. No, we are doing this because we are introducing this new part of it. So let's test and let's validate the solution. So we can have in the first 6 months AIs evaluate doing that, and every sales order goes to draft and needs to be approved by humans. And then after 6 months, we evaluate how much were the false positives, how much were the correct orders, and we calculate. And we come to the conclusion that the agents got 98% of the sales orders correct. So only 2% failed, right? What was the cost of this? The cost was, for the ones that fell, it was 10K. Okay, perfect. What was the cost of having 10 salespeople approving the orders? Oh, it has the salary, it has this cost, so it's 20K. Okay, so now we have a use case where we can accept those 2% of failure of AI, because even those 2% can compensate the cost of having human activity, right? So with AI, it's never about precision. AI will always fail. We need to put the most possible number of guardrails, security, instructions, validations. We can do that, but we need to assume that an AI agent is like a human. It will fail. It will give errors. So we just need to consider that we have an use case necessary to put AI, and then the human in the loop should be also considered as an analysis to the case. Because do not forget that human in the loop also costs time, because basically we need to have humans checking, right? So it's always an evaluation. So well, let's play again a similar game that Killian did, but it's not on the Menti. Menti, it was a really good idea, but I have it here in slides. And please use the chat, guys, to consider if something can be a use case for an AI feature or not, or if it depends. So we have the yes, no, it depends. Okay, so let's see how how is the room environment here. So we need to build a ticket support agent that can read help desk emails, and then he generates a ticket in the ticketing system. So he fills the title, the date, the priority, the requester, and the description. So the only goal is for him to do this. Let's not assume anything else outside this scope. Do you guys think that this is a use case for AI? It should be given to automation, or it depends? Killian started with automation and then it went, wait, no, thinking better. It depends. Okay. So you +1 in the comments. So yeah, this mostly can be done using an AI agent. Of course, that probably, Killian, you were thinking of a scenario that the AI agent will need to connect somehow to an API or to call a service action of the ticketing system, right? So we can consider the whole solution of creating a subscription in Microsoft Outlook to receive an email has automation. Also, the service action of putting the tickets in the system, it's also automation, no doubt about it. But the central part. Okay. No, I think that because we are not so many, we can use the chat. It's okay. Probably it's simpler. But in this case, the medium part, so the decision part of this process can be almost done by AI with correct instructions, because first, the email is an unstructured communication and a ticket is a structured communication, right? And of course, there will need to be rules, no doubt about it. In the same way that if you guys hire a junior person to do this help desk job, that person will need to have okay. So the person will also need to have a manual book, right? So if a person comes for the first day, someone will give him a book saying, hey, if the client is considered a tier 1 client and he is not happy about this, it's considered a high priority. If this is this, it's a medium. This, it's a low. So there will need to be rules, right? But even those rules, they are unstructured rules, right? So this can be given as an instruction to the AI agent, right? So yes, in this case, it's a really common use case for AI. Let's go here to the second one. Build a data validator agent that receives a JSON file and then checks if in those fields if the data is correctly filled. So for example, if the data format is correct, if it is text, number, or a date, and if it has, for example, if it is a text, if it is below 500 characters, and then he stores that on the database. What do you guys think? This is a case for AI or not? Okay, Killian says automation. Jasper also says automation. Okay, so yes, you guys are totally correct. This is not a use case for an agent. And for example, this is an error that I think we can see in the Forge, that some people are, guys, let me just take away the phone because it got out of battery. Okay, can you guys hear me now? I'm here. Just put a yes or no. Yeah, perfect. Thanks, guys. So yeah, this is an error that you might see, for example, in the Agent Forge, that there are agents there that are used to do deterministic validations. And for example, a data validator, this is deterministic, right? You guys can use the built-in functions of Outsystems to check if it is a text, if it is a number, if it is a date, if the length is above or below, right? So this is deterministic behavior. So there is no need to create an agent for this. Third case, build a medical advisor agent that picks the full historical data of a patient, and based on all medicine knowledge that he has, he builds a report and sets a group of actions, treatments, and appointments for the patient. So what you guys think? Agent, automation, it depends. Something in the middle, more to agent, more to automation, more to human. Okay, this is an interesting. Okay, yeah. Jasper put it here. Really important topic, that it is not just because AI can solve things in an accurate way or even in better way than humans that it should replace humans. Because when we are talking about sensitive fields, areas that depend a lot on how we humanly deal with the situation, right? We are not only talking about correct or incorrect decisions. Of course, it's always good to make correct decisions, but we are also talking about the humane part, right? We could always build an agent that would give bad news to a person saying that she has a health issue or something like that. It's possible. The agent can be super humane. He can say all the correct things, but in the end, he's still an agent. And that hospital is choosing to put a machine to give a bad news to a person. So there is this concept that sometimes things just need to be done by humans. It's our job in that way. Like it's like if we have a company, we have a junior, we have a manager, and there is a big issue in the project, we will not throw the junior to the lions. The manager should assume this, go ahead and talk and deal with it. It's a sort more of a responsibility to it. So when we are talking about medical, it's a whole sensible area. But it doesn't mean that we cannot use AI. And we should use AI because AI can have a really accurate way of gathering sets of information from different sources, find patterns, and advise doctors on where to go. So there can be indeed a system where the AI does this, and that. And in the end, it gives a report to the doctor saying, according to my analysis, I advise this, I advise that. These are the sources that I consider. This is the information I consider. So this means that there is a hybrid approach here, but a human, it's always better to deal with case sensitive situations like this. Then case 4, build an IBAN validator agent. So an agent that picks each transaction of a certain business and then validates if the IBAN number, if it is a valid number. So basically he checks if it is valid or not, and then if it is valid, he puts that into verified. Okay, you guys didn't give me time to finish. You already said it. Yeah, this is automation, because anyone that knows a bit more of IBAN, they know that the IBAN, to validate an IBAN, it's basically a set of calculations, like picking this character with that character, if it gives this, exactly. Like Anu said, it's a deterministic situation, so no doubt about it, this is a case for automation. Finally, last one, build a financial transaction agent that picks a set of transactions. So there is some similarity here with previous ones, that picks a set of transactions of businesses and verifies if the data is correct. So if the description has all the necessary details about the product and the store, and if so, he updates the status to verified. What you guys think of this one? Can this be an agent or not? Okay, so yeah, Jasper touched here a cool point. So in reality, yes, this can be a scope for an agent, but as Jasper said, this is also a combination of automation and the agent, because we can use the service action ball that we did before for the case 3, right, where we checked if the fields are in the correct form, syntax, and below 500 characters. So that part is deterministic. But then we have here the part of the description, right? Because the description, someone might put this like payment of product, payment of the acquisition of the 10 filters in the Lisbon store, or it can say this was a transaction made in Rotterdam to buy 5 filters. So those two descriptions are completely different, but both of them have the product and the store information. So we need an agent to interpret this. So in this combination, yes, we can build a financial transaction agent that inside he uses some tools to verify in a deterministic way some things, but then he also needs to evaluate others. And I think this was my last slide, because the other one, yes, this was more if we would have time to go more deep dive into some things, but we are 2 minutes away. So I just wanted to ask guys if you have questions about this. I think this was the way Killian introduced the agent versus zombie part of it. It was really important because it shows a practical example of a journey of how we can build it. In my case, I can say that the difference that I implemented, the difference that I did it was that I didn't create any decision algorithm. So Killian created the decision algorithm and then perfected. In my case, I put completely the decision on the agent. But what I did different is that I prepared a full set of information to give to the agent in each run. So I built a virtual map to give to the agent. So on each run, the agent would receive a sort of a markdown made map with the letters saying if it was a safe square or if it was dangerous or fog or something like that. So basically what I imagined was, okay, if it was me, a person walking around in that graveyard, first of all, I wouldn't do it. But if it was me, what what would be the necessary information that I would need to make a correct decision. So I would need to draw a sort of a map where I would check the things on the go. I would run and I would say, okay, this one is good, this one is not good. So I would build the map on the go. Probably I would also want some details to help on this cemetery, saying, hey, be aware of the fog things, be careful with the edge, do not fall. So I would want someone to give me a sort of instructions. So I built those in a deterministic way, and then I gave it to the agent, and then I said, okay, agent, do what you think it's best to do with that information. So it was also mixed, but more in this case, the decision part was given to the agent. I see that Jasper did here put here a question. Let me check. How much of this have you used in practice yet for clients with Outsystems agents? To be honest, and this is a really difficult part, not so much directly in production in clients as I wanted. We are working with clients to explain this and to help with this. Unfortunately, AI is something that needs to go through a lot of steps on the businesses. So most of them, they like the ideas, they understand the ideas, but there is still that moment where they say, okay, we need to think about it, and then they need 1 month to think and to go forward with it. So unfortunately, a lot of these use cases we have already built, we have already showed to clients. Some of them we could put it, for example, in dev and so on, but so far I didn't have yet a client using a more heavy use case in production. So we are pushing on that part, but unfortunately, this is where the human risk comes. So yeah, but most of these use cases, at least we already have accelerators on our side. So we already have email reader agents ready to be put it. We already have, for example, voice agents ready to be put it on a phone number. So if we call, instead of picking up a human, he picks up an agent. So we already have these accelerators, but unfortunately, not yet in production. That, yeah, it's more for the clients to decide. And I think there isn't any more questions here. So I think I can give the word back to you, Anuj. Thank you.
Okay, I'll stop the recording maybe. And